So today we're going to discuss Anthko's theory of time and the Big Bang Theory. Anthko's theory of time supports the Big Bang Theory, but unlike other theories that revolve around the Big Bang Theory, Anthko's theory of time actually explains the how and why the Big Bang happened, and it builds upon our last video about Anthko's theory of time and black holes. In that video, if you recall, black holes, according to Anthko's theory of time, have a super viscous solution of temporal quanta, which causes the passage of time to greatly decrease, but the effects of time to greatly increase, meaning time passes more slowly, but things age and mature and evolve much more quickly. And the idea is that temporal quanta are exotic particles that do have a half-life and eventually break down. And much like water, boiling water, the bubbles in boiling water, how pockets are formed within the water that don't have the same viscosity or density as the surrounding water. And that's the important part, that pockets are formed within a substance that don't have the same viscosity or density. In a black hole, according to Anthko's theory of time, these temporal quanta break down and create time pockets. Within those time pockets, other exotic elements, which are created from the dissolved or crushed, aged out leftovers of everything that's entered the black hole horizon, combine, and you get exotic particles that very rapidly are created and die or explode without having the ability to interact with each other. But within these pockets, time passes very slowly, so they have the ability to interact with each other, these hyper exotic particles in the universe. And then you start getting things like star formations, galaxies, and things all within a black star. Or, I apologize, not a black star, all within a black hole. So inside of a black hole, you have these empty pockets of time, which have galaxies and stars and other things that are very exotic in the universe, and some less exotic stuff. Just some standard matter could collect to create planets and things of that nature. But the important thing is that these pockets over time grow in size or in amount and reduce the mass of the black hole. As that happens, the structural integrity of the black hole starts to decline, and then once it gets to a critical decline, it actually, for lack of a better term, supernovas and implodes to explode, implodes, and sends all the matter in the accretion disk flying outward, and the accretion disk is fairly flat, so everything in the accretion disk, when it flies outward from this supernova, actually flies out in a fairly flat pattern, which supports the general principle of a flat universe model. But then we have these other things that are inside of the black hole that also are scattered throughout the universe, and those are scattered in a much less flat pattern. So you will, according to Anthko's theory of time, see universes and other universal bodies that are not aligned with the flatness of the accretion disk, above, below, parallel to, things of that nature. And that's how Anthko's theory of time both supports the Big Bang theory and explains the how and why.